Hi, good afternoon or good morning whenever you're watching this. This is lesson 9.2. We're going to talk a lot about transformations of quadratic functions today, okay? Transforming it means taking a parent function, which is x squared, which looks like this, and we're going to take this bad boy and we're going to move it all around, we're going to flip it, we're going to do all sorts of things with it. But what we want to make sure you guys understand is how to transform it and then what the little pieces mean as we go forward. Okay, so two things in here. Transformations of quadratic functions is pretty simple setup. We didn't have bell work, and so instead we're going to go right into the lesson. Transformation, translation, dilation, reflection, and vertex form are the things we're talking about. So vertical translation, what did it mean? Okay, what does it mean? It actually means taking this k value, okay, which is this value right here, and it's part of the vertex form of the equation. Whenever you have x squared plus k, the k value moves the graph up and down depending on if it's positive or negative. Okay, so x plus 10 means you go from the original function and you go up 10 points to right here. This is a vertical, this is a, not vertical, it's translating 10 units up. Okay, if you got the notes from me later on in class, please make sure you know that. This one here goes vertex and it goes down because it's negative. So this translates, and this is the only time we write the word translates, 8 units down. Okay, that's this functionality. Then what we do is we go forward and make sure you guys know on the guided practice, you figure out which way it goes. All right, and this you just tell me which way it goes. This is going to go down 7. This would be up 5. This is going to be down 5. And up 1. Next is the h. On the h value, okay, one aspect of the h value you guys need to make sure you see is that the h value is within the brackets. So we're actually subtracting it from the x before we square it. So if the value is inside of the bracket with the x, then you would move it left to right. Now this one's a little tricky, okay? And what I mean by that is if h is greater than, of course it's going to go right. If it's less than, it goes to the left. But there's a slight trick to this. The formula is supposed to be h minus, or sorry, is supposed to be x minus h squared. Okay, this is the same thing. H minus x, did it again, sorry. X minus h squared. Okay, that's our setup. The question is what value is this? Well, so what you're doing is x minus, and then we're going to throw a number in here, and we're going to square it. So how would I go from a minus to a plus? Well, this number in here is technically going to have to be a -1. So if I put a -1 in here, then what happens? 1 and 1, it would turn into x plus 1 squared. So that's what I want, which is why this goes from here and it goes left 1. So we go left 1. Okay, and this one here, x minus, so it's the same setup, x minus, and then what smaller number do we put in there to make it still 4? It's going to be a 4. If I put a 4 in here, does it change this equation at all? No, it just becomes x minus 4, right? Hopefully you guys understand that. So this one, you go 4 units to the right. Okay, you go right 4. Hopefully you guys get this, okay, on the x part. So this illustration, hopefully you guys understand and see that it's always supposed to be x minus. But if you end up with a plus, that means you had to put a -1 in here, which changes the sign, which means you go left. Even though this looks like it's a negative, it's technically not. It's a positive, and you would move it to the right, okay? Work on these two. All right, this functionality, since it's already a negative, I'd go right 3. And this one, since it's a positive, that means technically this is a -2, and I would go left 2. All right, so that's kind of the setup on the h. Now we're going to put the pieces together as we move along. And what this means is here is plus, so once again, this is supposed to be x minus, and it's not, it's a plus, so that means it's going to move left 1 and up 1. Okay, and you guys can see it goes left 1, up 1. This one right here, it's supposed to be x minus 2, and it is, so that means it's going right 2, up 6. So I'm going right 2, up 6. Now the scale is by 2, 4, 6, 8. So just think, oh, I'm supposed to go over 2 more. No, you're not. You're just going. And so what does that mean? Well, if you were to go on my thing, and I'll show you in a second what it actually means based off of this. So work on this real quick. Make sure you guys can do it. All right, remember this would be a negative 2 coming in here. So this would be left 2, and then it's going to go up 3. And then this is going to be going right 4 and down 4. Okay, so technically speaking, you would go from there. So let's look at what that actually means. So on this one right here, I know my value if it's x minus. So I can actually set it up in decimals where you can type in a by going to the other keyboard, a bracket x minus h squared plus k. And then what happens is there's a little option that will say a slider for AHK, and you can hit all, and so it adds a slider. So right now I'm at x squared because h and k are 0. All right, but if I go back to my original equation right here, okay, and I look at this, what happens is that if I were to put a negative 2 in there, like I'm asking, and then go up 3, you can actually go into decimals, and I can go negative 2, and then I could go up 3, and you guys, hopefully, I didn't block it the whole entire time. So this is going left to right, it's 2, and then this would be going up to 3, and you guys can see the transformation as it moves. So we went from here, and we went left, and then you saw the graph move. Okay, that's a big key aspect, making sure you guys understand how this setup works. Okay, and then there's back to the apparent function. Okay, so now, ladies and gentlemen, what I want to make sure you guys do is understanding there's also called dilation, where we're going to stretch it vertically and we're going to stretch it horizontally. Okay, stretching it vertically is taking x squared, which is just like this. Okay, we're going to take this graph right here and we're going to either stretch it vertically, which means it'll shrink in, or we're going to stretch it horizontally, which means it goes out. And what is that value based off of? Well, it's based off the fact that if it's between anything over 1, the a value, okay, so on this equation right here, here's my a value, because my a value is always in front of the x squared. Okay, anything between 0 and 1 is what's called a horizontal stretch. Anything greater than 1, which in this case is 2, would be what? Actually, it would be 2x times 2x, which would be 4x squared. All right, that's technically what this is. And then this is what's called a vertical. All right, and the reason it's vertical is because it's a greater a, which represents 4, is greater than 1. All right, so what I want you guys to do is please try these two real quick. We're going to wrap it up. So this is going to be a vertical stretch because it's greater than 1. And then this is going to be horizontal because it's between 0 and 1. Okay? Now last piece of the puzzle here. Okay? Whoops. Didn't mean to add any page. It's called reflection, where you're going to take the graph and you reflect it over the x-axis or reflect the graph over wherever it's at. Okay? Reflection basically means you're taking and adding a negative. So if I go to decimals here and I take my a value, it's at 1. And you guys see if I move it like this, okay, so it gets horizontal stretch until it gets to 0. And then if it goes negative, you can see the graph flips upside down. So this would be negative 1/2, or negative 1/2 for a. And then it gets to 1, it's the same parent function, just negative flipped upside down. So if it's negative, it's flipped. And the big key thing I want to make sure you guys understood as we did this is the range. Okay, so what I want to make sure you guys looking at this from the green to the green graph is, what does this actually mean? Is that the y is the range on this, is every value of y is going to be less than or equal to 0. And that is because if you plot the points, that's kind of where it sets up. This is going to, and then this is also a vertical stretch. Okay, and then this one here is horizontal. But negative and negative. So if I had 1/2 x times negative 1/2 x, what happens to the negative in this case? It actually would go positive, and it would be a positive 1/4 x squared. Since this is positive, ladies and gentlemen, you have to understand that this is the y value for this would be every number greater than or less than 0. No reflection. All right, so what I want you guys to do is try these 3 real quick. Tell me if it's a reflection or not. All right, if I were to graph this one, this is a negative x, but if you square it, it's actually positive. So this is a positive value, and so remember what we're looking for is, what is it? This would be vertical stretch. All right, vert stretch. And we know the range is going to be every value greater than 0. And then this one here would be horizontal stretch. And then this is going to be y. 0 is the greatest value that you would have. The reason I know is because it's a negative number and it's flipped down. This one right here would be a vertical stretch. And this would be the same thing. Negative times a negative would be positive. So if it's positive, it's going to be the same as this one right here. So it's every value greater than 0. Okay? Just make sure you guys understand the principles as we go through. And now what we're going to be doing is we're going to talk about kind of, and I'm going to end it pretty quick with these equations. Just knowing what it actually means and how you go from there. On this, ladies and gentlemen, the big key aspect of this would be to understand what your A, B, C values are, okay, what your H and K is. So this one here, this graph goes from the blue to the green. So how does it go from blue to green? Well, first off, it goes up 1.53, okay, and then what it does is it goes right 3. And then after that, ladies and gentlemen, the graph actually flips upside down when the A is the negative. Okay, this is going to have a horizontal stretch. I also want to know the vertex. Okay, my vertex is my x value, and then it's 1.53. Okay, and then last but certainly not least, ladies and gentlemen, you have to talk about the transformation of it. Okay, which way is it going? It's going down, and what is my range? My range is going to be y is less than or equal to 1.53. All right, please do this one real quick, and you guys, and then we'll go from there. All right, same thing. This right here, I know if I were to graph this in Desmos, I'd be able to put this together, but I know that my graph moves up 1.5. It goes right 80. My vertex is 80 and then 1.5. And then I also know that it is a horizontal stretch because this value here is less than 1. I do know it goes upside down, and so my range is going to be y is less than or equal to 1.5, okay? Because the graph actually is going to be a maximum. And then I'll write that in there too, it's a maximum point. All right, sorry, bad handwriting. All right, if you guys have any questions on this, please let me know. But what I want to make sure you guys understand is how things relate to x squared. Last but certainly not least on here, as I walk through this with everybody, there's a couple more things on the notes, but we really didn't get to them. It's talking about the g of x. So I'll do the green on this one. All right, and on the green on here, it's talking about how does this, by looking at this function, I graphed it for you, but by looking at this functionality, can you put the pieces together? What I mean by that is, do you know that the graph goes up 3? Do you know that it goes left 1? Do you know that the vertex is negative 1, 3? Okay. Do you know that this is a vertical stretch? Okay. And then do you honestly know that the axis of symmetry is on this? Axis. it'd be at this point here, which would be at -1. Axis symmetry is at -1. And then that's kind of it. And then the range, what was my range? My range on this one is 3. Y is greater than or less than or equal to 3. So please make sure you guys understand the principles on these. And then you guys do this last one real quick. Up 2. We would go left. Not left, but right. Right 6. The vertex. The vertex on this would be 6, 2. And then what is it's a vertical stretch or horizontal. This one's a horizontal stretch. Okay, and then axis of symmetry is what? Axis of symmetry is x equals 6. Okay, and then what is my range? Okay, my range is going down. So my range is it's going down greater than or equal to 2. And that, ladies and gentlemen, is it for the lesson. We talked a little bit about these, but we really didn't go into any functionality of it. There's a couple more pieces, but we didn't do it in class, and maybe we'll get to it after a while. If you have any questions on this stuff, remember it's about moving, manipulating, and figuring things out. Okay? If you have questions, ask me. Use Desmos. Try using this functionality in Desmos as you guys move along. Okay? Try using this. Understand that you can take this graph and you can move it to the right. Then you can flip it upside down, going this way, or flip it right side up. And then you can go up or down with it by doing this. And when you do it, you're kind of seeing the graph move. But we all started right here at 0, 0, where this is 0 here, and the h is 0 right there. Okay, if you guys have any questions for me, please see me in class. Sorry, I didn't quite put it at 0. Please come see me, work with it, understand what the graph is doing. When you understand what the graph is doing, you'll be very successful in doing this. All right, in the meantime, come see me if you have anything, and I'll catch you guys later.